I'd been on the hunt for an AMSTRAD CPC 6128. It was the first computer I used in school until 1994 when IBM compatibles took over. In Australia, there was a small market for AMSTRADs in the 80s. However, finding one now in working condition and a reasonable price can prove difficult. When I went on eBay, I saw a heap of AMSTRAD CPCs being sold by a seller in Australia, so I grabbed one. According to the ad, it was untested and did not include a power supply or video cable. For 280 Australian dollars, it was a pretty risky purchase. Did I buy an expensive lemon? Let's check it out together. Hello and welcome to Evan's Retro Lane. I finally got hold of an AMSTRAD CPC 6128. It's been over 32 years since I last used one. I have great memories of this computer back when I attended Croydon Park Primary School in South Australia. The CPC was introduced to public schools from 1987, replacing the Commodore 64. It had a good selection of educational titles and games. Some of the popular educational titles were developed by the nearby Angle Park Computing Centre, funded by the South Australian Department of Education. Some of you might be wondering, what is AMSTRAD? AMSTRAD was a consumer electronics company founded by Alan Sugar back in 1968. The name AMSTRAD is derived from the initials of Alan Michael Sugar, followed by the word trading. AMS Trading was the first registered business name, which over time became AMSTRAD. Now, what is CPC? Seeing the success of Commodore and Sinclair personal computers in Europe, AMSTRAD set out to create their own line of personal computers. The AMSTRAD Color Personal Computer, or CPC, was introduced in 1984. A goal AMSTRAD had was to create an all-in-one system, taking away the complexity of setting up a computer with an assortment of peripherals. That's why you'll find everything you need built in or supplied with the CPC purchase. The CPC 464 has the inbuilt cassette drive, and the later CPC 6128 has the built-in floppy disk drive. CPCs came with a dedicated monitor. What differentiates this computer from others is that the monitor provides the power to the computer, and the computer outputs an RGB video signal back to the monitor, which is why we have a challenge to get this computer connected now. Before we begin, a huge thanks to everyone who liked, commented and subscribed to the channel so far. Subscriptions really do help this channel, so if you enjoy these videos and you want to show your support, just take a second to hit that subscribe button. And if you do enjoy the videos, just give me a thumbs up. More than likely, if you purchase an AMSTRAD CPC, it will be without the dedicated monitor. Here's what we'll need: a 5V power supply, an audio video cable 5-pin DIN to RGB SCART, and a SCART to HDMI video processor. The AMSTRAD CPC 6128 requires two power inputs. One is 5V DC and the other is 12V DC. The good thing about the CPC is that these power inputs are separated. I can operate the computer with only a 5V power supply, but if I want to use the floppy disk drive, I need to connect a 12V power supply as well. There are custom-made CPC power supplies available for purchase online catering for both voltages, but I can't justify spending 70 Australian dollars and an additional 40 Australian dollars for postage just for a power supply. So I ordered a 5V 5A power supply for 20 Australian dollars. Two things you need to know is, number one, it must be inside or center positive, and number two, must be a 2.1mm male connector. The plan is to insert a step-up converter, which can be purchased for a few dollars from AliExpress, which connects to the 5V line to generate the 12V we need. Secondly, we need a cable to connect the video output to a TV. The other unique thing about the CPC is that it outputs an RGB signal, rather than a composite or S-video signal like we see on other computers around the same time. The positive is that it does give a clearer picture compared with other computers, but the negative is that regular TVs don't have an RGB input, hence why CPCs came with a dedicated monitor. Fortunately in Europe, they adopted the SCART connector. This is an all-in-one connector and is capable of providing multiple formats over many pins, including RGB. All you need is a TV or monitor that can decode the RGB signal via SCART. Easy, right? Well, not if you live outside Europe. For that we need to purchase another item. I found and purchased this SCART to HDMI video processor for $50 Australian, which specifically mentions it supports RGB. Alright, we now have all the items needed to connect this AMSTRAD up to power and a modern monitor. I'll put links or at least the names of these items in the description in case you'd like to purchase them yourself. Looking back at the eBay listing, this CPC was sold untested. The seller mentioned that they switched it on using who knows what kind of power supply, and the LED came on. We also know these AMSTRADs were sitting in storage for 20 years. This really was a high-risk purchase. I was happy to see when I received it that it was in fairly good condition and all the parts were included, such as the disk drive. The first thing to do, as I did with the VIC-20, is inspect the motherboard and components, ensuring we remove any dust, especially if it had been in storage for 20 years. We flip the CPC, exposing the back panel. We remove 7 screws from the back and 2 from the side, alongside the disk drive. With the CPC, we need to be extremely careful when removing the top part of the case because the keyboard is attached with 2 ribbon cables. So best to lift it up from the side where the disk drive is. We'll give it a proper clean later. For now, I'll just brush away any dust with an anti-static brush. Next, I'll just check all the components on the board. There is a small cluster of electrolytic capacitors on this board. I previously mentioned they can pop, bulge and leak, so they need to be checked. Everything looks to be in good condition though. I'm hopeful this will work. I'll take this opportunity to clean up the edge connectors because I know I'll be using the expansion port in this video. For that, I'll use IPA and cotton buds. Of course, you can use an eraser or even a fiberglass pen. Because I've purchased a new power supply, there isn't a need to test it. If you have an older one, or if one was supplied, best to test it first. I'll reassemble the CPC and we'll give it a test with the new 5V power supply and the SCART RGB to HDMI converter. This cable I purchased for the audio video signal is important because you can plug in the 5V supply into it, which then goes into the actual 5V input on the CPC. The reason is that for the RGB signal over SCART, 1 to 3 volts is required on pin 16 to tell the receiver there is an RGB signal. Otherwise it will default to composite. Pin 8 also sends voltages relating to a particular aspect ratio. The other great thing about this cable is that it provides an audio cable to go from the headphone jack of the CPC into the SCART connector so we can have sound through our HDMI connection. The CPC monitors didn't have speakers. Instead, AMSTRAD included a single speaker in the CPC right here, which can be controlled by the volume wheel next to it. Now that I've connected it all up, let's see if this untested CPC actually works. The power switch is located on the back. Well, look at that, it worked the first go. Researching all these connectors and requirements really does help rather than just plugging in anything and hoping it works. So I notice it says AWA here instead of AMSTRAD, which is interesting. Apparently AMSTRAD allowed this to be customized depending on who was selling the CPC, and there are a few links on the motherboard that control what gets displayed. In Australia, AWA was the distributor until 1988. In Germany, their CPCs carry the Schneider name. Let's check the keyboard. It works, but some keys feel a little stiff. I don't think this is the best keyboard out there, but anyway, we can give it a clean and hope it works better than it does now. The keys can do with some retro brighting though. Alright, so the computer turns on. What can we do with it? At the moment, not a lot because the disk drive hasn't got any power. We can write a basic program, but that's about it. I was looking online for a solution to load programs without a disk drive, and it looks like the Gotek Floppy emulator is a popular choice. However, I really didn't want to replace the disk drive with a Gotek unit, and even for an external unit, Some mods need to be made in order to power the unit. The other issue is that the GoTech costs around 50 Australian dollars and always seems to be out of stock. They are popular because they're used for a variety of retro computers, including the Commodore Amiga. When browsing Gumtree, I happened to come across this. It's a USI FAC2, which stands for Universal Serial Interface for AMSTRAD CPC, already assembled for 30 Australian dollars. After checking out the details, it looks like I'm able to load disk images and seems to have a heap of features claiming to be the GoTech killer. Not sure about compatibility, but we'll find out soon. I'll turn off the CPC. This device plugs directly into the expansion port at the back. No other power cables or mods need to be made, which is great. You can get a 3D printed case for this too. I'll insert this USB stick I received from the seller with a heap of CPC programs. Turning the CPC on, I can see the device has been detected and additional messages are displayed on the screen. I had to learn how to use this thing. I found the user guide online, which was very helpful. I'll leave links in the description. In a nutshell, commands begin with the pipe symbol. By default, this unit has activated USB emulation. Otherwise, you would simply type pipe USB and press enter. Then we can type pipe cat to get a listing or catalog of the files and folders on the USB. To start with, let's run a diagnostics tool to make sure that we don't have any issues with the video chip, RAM, ROMs and inputs. I've got a heap of basic programs which are shortcuts that mount the necessary disk images and run all the commands. All we need to do is type run, quote, diag, end quote, and press enter. Check out the contents of this bash file in case you want to create your own. You can see that I store the name of the directory in variable A. Change to that directory, store the disk image name in variable A, mount it, switch to floppy disk controller emulation, then run the diagnostics program. Okay, let's run through these diagnostics. First, we'll test the lower RAM, which ran when we started the program, so that passed. Next is the upper RAM, and that passed as well. So that's great, we have good RAM chips. Let's test the ROMs. Looks like it found the 6128 basic ROM, some unknown ROM, I'm guessing that's the USI FAC device, and the AMS-DOS or AMSTRAD DOS ROM. So we're looking good. Testing the keyboard and a joystick port also passes the test. I'm very pleased so far. This purchase could have been an absolute disaster. So we have a working system. Let's quickly check out a game. A game I immediately think of is Bomb Jack. My school had a copy and we used to all love playing it. Let's load it up. The good thing about the USI FAC is that I can reset the computer by pressing a button, rather than wearing out the on-off switch. Let's type run, quote, bomb jack, end quote, and press enter. Seeing this really transports me back to a 9-year-old. Let's turn up the sound on this built-in speaker and listen to whether it works. These sounds are so nostalgic. I've got goosebumps. Now let's disassemble the CPC for cleaning and restoration. To start, we flip it over and remove the 7 screws from the back and the 2 from the side as we did before. Remember to carefully lift from the disk drive side, laying the top half face down on the left-hand side. Next, gently pull the 2 ribbon cables with 2 sets of fingers evenly from their sockets. Then remove the 12-volt input cable by unplugging it from the motherboard. Remove the 2 screws holding the disk drive in place, lift the disk drive up and remove both the data and power cables from the back. Now there are a few long wires running across the case to various parts like the volume control, the speaker. I might remove some and just leave others in place, as long as I can maneuver the motherboard. Remove the 4 screws holding the motherboard in place. This screw here near the data cable can be tricky. Next, detach the volume control by releasing it from the plastic clip holder. I can now fully remove the motherboard from the bottom half of the case. Next, I'll remove the keyboard from the top half of the case by removing these 3 screws. That should do it. Alright, now that we've disassembled the CPC, let's focus on the plastic case. Using regular household cleaning sprays like Windex, I'll wipe away all the dirt and dust starting with the top half. Now for the bottom half. The labels on the CPC seem to have a metal backing and the tops can be easily scratched. It even seems the paint is wearing off as well. The plate above the disk drive has faded a little. Cleaning it could have made it worse, and it looks like someone has marked it with some white out. That will be hard to remove without scratching it even more. I purchased some replacement stickers from the Badge Man, which are available from Retro 8-Bit Shop. I'll leave a link in the description to their online store. Let me see if I can get the surface of this plate as flat as possible before I apply the new sticker. Once done, apply the sticker carefully. There we go. Looks good. I also have a sticker for the main name badge, but I don't think it's bad enough to replace, so I'll leave it alone. Now for the keyboard. When testing this before, it seemed to work. Some keys seem a little hard to press depending on the angle. Not sure if that's how they normally are, but anyway, we need to take it apart and clean it up. So we need to remove all the keycaps. This can be done by gently pulling them up. If it's easy enough, use your fingers to gently remove them, or if they seem difficult, use the keycap puller. I keep the keys and the springs in order on my mat, so I can easily place them back later. Leave the return, both shift keys, control, copy, space and enter keys alone for now, as they have an additional metal piece holding them in place from the rear. Flip the keyboard over. To remove the metal backplate, press the plastic clips inward. The plate should detach from the plastic holder. The keyboard membrane is then exposed. This can be removed for cleaning. Then we can remove the remaining keys by removing the metal rods, then continue as we did with the others. Keep the spacebar spring separate as it is different. Now we clean the plastic base using Windex. Then use IPA to clean the membrane. Now before we retrobrite these keycaps, they need to be absolutely clean. I'll just quickly wipe over them with Windex. We can't really use the same retrobriting method I did in the previous VIC-20 episode because the keycaps are light and they would just float to the surface of the water. So for this restoration, we need to use the cream version of hydrogen peroxide. I bought this bottle from a pharmacy which is rated at 12%. For this, ensure you wear gloves and provide an even coat to each key, laying them face up on a piece of cardboard, or use any flat surface covered with plastic wrap. Once done, seal the keys with plastic wrap so that the solution doesn't dry and leave them under the sun for 2 to 3 hours. Ensure you check on them every so often. When you see the keys have visibly improved, submerge them into water to rinse thoroughly. Then dry them, ready to be reassembled. Turning our attention to the motherboard, luckily it all works from our initial testing. So for this video, I'll give it a thorough clean using IPA and some cotton buds. If I did need to replace any of these capacitors, I would do it now. But seeing that there aren't any issues or visible leaks, I'm going to leave them in place. I'm going to spray the entire board with IPA and just go around with some cotton buds to remove any dirt from the board and components. I'll repeat this process for the underside as well. We still have the issue of not having a 12-volt supply running into the computer. Looking at the floppy disk drive, you can see the motor clearly states it requires 12 volts. The parts I ordered from AliExpress have arrived. I ordered a step-up converter which can take 5 volts and output a maximum of 28 volts, and some female power cables. These parts only cost me around 15 Australian dollars. The modification I'm about to make is only if you intend to use the floppy disk drive. Given the USI FAC device works well, I could just use that. But I'm curious to see whether this drive works, and for the sake of completeness, have the entire computer working as originally intended. I've already soldered the cables with 2.1mm female plugs to each end of the step-up converter. One side will connect to our 5V source, and the other side will output 12V and connect to our 12V input cable. Just a note about the 12V side, it needs to be center negative, which is why I've reversed the wires. Before we connect this up to the motherboard, I mentioned this converter can output up to 28V. You don't want that going into this computer. I need to ensure the step-up converter outputs a steady 12V. For that, there is a small potentiometer on the board which can be used to configure the output. Before I cut the wires on the 5V side, I'll plug this in directly to my 5V power supply and test the output. So we can see 5V coming into the step-up converter and 12V on the outer barrel on the output. Excellent. I'll then cut the plug off the 5V input and solder one wire to a 5V source and the other to a ground connection. Last thing to do here is secure the step-up converter board so it doesn't move around, and we should be ready to go. If you're not familiar with CPC computers, the disk drive looks normal, but it only accepts 3-inch floppy disks. These were included before the standardization of 3.5-inch floppy disks in 1986. Let's do a quick inspection of the drive. The read-write head is located here, which you can access by lifting this plastic piece. I'll clean the head with IPA, then remove dirt and dust from the rest of the drive with cotton buds. The other important thing to check is the rubber band, which is visible under the drive. So for that we need to remove a few screws to check. That looks to be okay. This either hasn't been used much, or it may have been replaced and stored away all this time. I can't see any reason why this drive wouldn't work. Now it's time to reassemble the CPC. We take our retrobrighted keys and carefully place them back onto the stems. Also remember to reattach the metal supports for the return, both shift keys, control, copy, space and enter keys. Next we insert our clean membrane and clip the metal plate back into place. Now that the keyboard is ready, we screw it back to the top half of the case. Putting that aside, we move to the bottom case. Let's bring our cleaned motherboard back in, screw it back into place, reattach all the cable connectors, connect the data and power connectors to the floppy drive, and then screw it back into place, ensuring the ground connector is also screwed into place. Let's make sure our 12V connection is also ready to go. Reattach the keyboard ribbons by sliding them back into place. Finally, let's close the case, flip it over, and reapply all screws. Alright, it's that time again, but before we see our final result, let's look back at what we started with. The CPC was sold untested, without the included monitor and any cables to connect it up. I purchased a power supply, audio video cables, and a video processor to ensure we could connect it all up. The CPC physically looked to be in good condition with minimal scratches and discoloring. The keyboard looked slightly yellow, and the label plate on top of the floppy disk drive was a little worn. Once we turned it on, luckily it was all in working order. So now, after a little bit of work, here is what we have. This AMSTRAD CPC 6128 looks great. The discolored yellow keys have reverted back to a bright, clean, light grey. A new sticker has been applied over the metal label that was scratched up and fading, keeping it true to the 6128 style. The keyboard has been thoroughly serviced and cleaned, ready to provide many more years of typing. But what about that floppy drive? Does it actually work? I bought the only 3-inch disc I could find for a decent price. It happens to be the worst game for this computer, but I just wanted something for testing. And it seems to load and run without an issue. What do you think? These computer systems are remarkable. They're robust and still provide hours of excitement not only to those of us who remember them from the 80s, but to future generations. I was really excited to receive this computer and give it some attention and see it in action after 30 years. I hope you enjoyed this small restoration project. How do you think it went? Hit that thumbs up button if you enjoyed it. Also check out my VIC-20 restoration if you missed it. Thanks so much for watching. If you haven't already, click on that subscribe button to be notified of new episodes. You can help support the channel by following the links in the description. And I'll see you next time.